This video is on communication matrices. So communication matrices are very similar to dominance matrices. So if you've already looked at the video on dominance matrices, then this video will be pretty easy for you to understand. If not, perhaps it's best to watch the dominance video first and then watch this one. So a communication matrix, I'm just reading off the textbook, the Further Maths textbook. So a communication matrix is a square binary matrix. So remember, binary means only zeros and ones, in which the ones represent the links in a communication system. So again, like dominance matrices, you'll be given a network like this, but this time, unlike dominance networks, arrows can go both ways, because communication can go both ways. So for instance, this one is about four people that are staying at a backpackers hostel, and they speak different languages. So obviously communication can be tricky. Eva speaks English. So E is Eva, who speaks only English. Yumi, which is the Y, speaks only Japanese. And Kim only speaks Korean. So obviously K, Y, and E don't have any edges linking each other because none of the three of them speak the same language as the other. But the W stands for Wong, who speaks all three languages, English, Japanese, and Korean. So W can link two ways to each of these three people. So this is a perfect example of a communication network where we've got W linking all of the other three, but the other three can't link with each other. Now, because there's four people, we need a 4 by 4 matrix, and if we have a look at the matrix here, just like dominance, the rows indicate the direction of the communication. So this is the speaker, this is the receiver. So E can communicate with W, and because they're all two-way arrows, W can also speak to E. This is going to be a symmetric matrix, which means it's balanced. It's the same's happening either side of the leading diagonal. Sometimes you don't always get that. You sometimes can get one-way arrows, and I'll talk about that in a second. So this is a communication matrix. Now, if we have a look at, just like dominance, we can find two-step communication, so we can square it. This indicates the ways that people can communicate with each other via someone else. So if we have a look back at the network, E can't communicate directly with K, but they can via W. So that's a two-step communication. So E via K, if we have a look at that, E can communicate via K once. That makes sense. Now, importantly here, if we're looking at the leading diagonal, these numbers don't really make sense. They're called redundant communication links. So E can't communicate with E, W can't communicate with W, so this leading diagonal is irrelevant. They will become numbers, but those numbers don't really mean anything. So this 3 doesn't mean anything. W can't communicate with itself 3 different ways. So the leading diagonal is redundant. It's just the other values that's important. And just like dominance matrices, we can find the total communication by looking at the combination of the one-step and two-step. So this indicates all the different ways that people can communicate with each other. Remember, the leading diagonal is redundant, so W and E can communicate one way. If we have a look back at this here, W and E can communicate one way. That makes sense. This one, Y and E, can communicate one way. Y and E can communicate one way, and that's through W. So that makes sense. An example of when you might not have, you might have one-way. Let's go back to here. An example where you might only have one-way communication is, for instance, if we're talking about people communicating via radios, for instance, protective services or special services, Defence Force, etc. So E might have a radio that can hear what W is saying but not be able to communicate back. So that would be a one-way arrow from W to E. So those sort of things can happen in communication matrices. A question you might be given, for example, this one's from 2017 Further Maths Exam 1, Question 2 in the Matrices module. And what I'd suggest is if you pause this now and complete this question and then come back to check the solution, that would be a great idea. So the question says, the matrix below shows how 5 people, A, B, C, D, and E, can communicate with each other. So the ones indicate communication. This is the sender, this is the receiver, and Esther wants to send a message to Bevan. So E wants to go to B. So we're starting with E. The sender, the original sender is B, and we want to get to E is the original sender, and we want to get to B as the receiver. So there's 5 different options here. What we're going to do is ignore those for now. We're going to start with E and see where we get to. And let's just document it here. So if we start with E, we've got to look at the matrix and work out who E can communicate to. So E can communicate to C. Now, if E is sending a message to B, now E has sent the message to C. Now C has the message. Who can C send it to? So C can send the message to D or E. Now, there's no point sending it back to E because then we're back where we started. So we would send the message to D. Now D has the message. D can send it to either A or C. No point sending it back to C, so we'll send it on to A. Now A has the message. A can either send it to B or D, and B is where we wanted to get the message sent. So that is our communication journey, E, C, D, A, B. So that indicates that E is the answer. So that's communication matrices, very similar to dominance matrices. So have a read through the textbook. Make sure you know how to do this, watching the video or looking through the textbook, and give those questions a go.